first identify a pattern. All right. What pattern? 1 and 9. When you add 1 and 9, you'd be getting 10. Then 2 and 8, 10. 3 and 7, 4 and 6, 4 and 6, 10. 5 and 5, 10. All right. 1, 9, 2, 8, 3, 7, 4, 6, then 5, 5. All this will be giving tens. All right, tens. And also there is a issue known as complement. All right, what is a complement? Complement is a number which we would be getting when we get the next biggest next. If it's a 2-digit number, what number will be added to it to get 3-digit number? If it's a 1-digit number, 5, what number should be added to it to get 10? See, 1 when added with 9 will give 10. 2 when added with 8 gives 10. So complement of 1 is 9. Complement of 9 is 1. Complement of 2 is 8. Complement of 8 is 2. So when you identify a pattern, you took from the exercises, you took around totally 5 minutes to work out the sum. All right, work out the sum. You got the right answer, but when you worked out mentally, the answer was really not the right one, and almost out of 3, first time 3, nothing. All 3 were wrong. The second attempt, out of 3, 2 was right. The last one, which was wrong, you worked out another 3 times to get the right answer. 3 times to get the right answer. And the time taken is more than 15 minutes for everything, the answer to be right. So this is where you're losing time. Now check with the question. I'm going to put a timer again. 52 and 48 gives 100. 52 and 48. 82 and 18 gives 100. 37 and 63, 100. 300. Okay. 56, 44, 100. 24, 76, 100. 98 to 100. 300. 62, 38, 100. 30, 70, 100. 85, 15, 100. 300. 95, 5, 100. 84, 16, 100. 51, 49, 100. 300. 4, 96, 100. 52, 48, 100. 20, 80, 100. 61, 39, 100. 400. For the same 5 sums, 120 seconds. All right. So 120, when I divide it by 5, I'll be getting 24 seconds. All right, 24 seconds. All right. The time taken first time was around 1 minute. You got the right answer, 1 minute. But here I'm explaining and slowly writing. But when I identify this pattern and start working on it, my speed would be really different. Okay, really different. So identify a pattern first. After identifying a pattern, observe what you can do there. Which way you can minimize your work. Which way you can minimize your work. Then you proceed. Then you proceed. Definitely, you would be getting the answers faster. All right. Okay. Now, let's go for 10 questions. All right. 10 questions. 1, 2, 3, 4, 5. So, these are the questions which I want you to work on. And these are the questions I want you to work on. 10 questions. Let's check how fast you can be. You can use your, if you want a simple, I selected these two. You can select it and proceed also. All right. Whatever, some question may need some extra details. Like, okay, what I put, I didn't add 100 plus 100 plus 100. For 100, I put a 1. Then finally, I converted this. This way, you can easily work on. Okay. So I'm resetting. Your timer starts now. Finished. 240 seconds for 10. Sorry, not 240. 140 seconds, 137 seconds for 10. 10 questions. Now you have completed this 10 questions in 140 seconds. 140 seconds. Actually, exactly 135 seconds you have completed. So one question here, for here, you took 13.5 seconds only. Remember, first time when you work for almost 15 minutes, and out of around 8 attempts, you got 4 right, 4 times right. And out of 8, it took so much of time and lot of mistakes too. Then after you started using pen and paper, you took for 5 questions, 5 minutes, 5 minutes. So one question, 1 minute. Then now, after understanding, is there a pattern and how we are going to work? Now you got all those 10 questions in 135 seconds, 135 seconds, and check the difference you can make. 13.5 seconds, all questions right. All questions are right. So time consumption is less here. Number one, time consumption is less. Answers are right. Answers are right. The total time taken is 2 minutes, 15 seconds. First attempt, 15 minutes. 15 minutes for 3 sums to get all 3 sums right answer and with 8 attempts. And this is 5 minutes for 5 sums. So you can be this fast without any mistakes, and you're going to get good score also. If this is proceeding in all kinds of questions, the time taken for you to complete all the questions will be very, very less, number one. Because these are the works which has to be done in school. They should understand the students' speed, what kind of mistake they do. If they understand those mistakes, there will not be any problem at all. So the way you work can enhance your speed 1/5. All right. That is, if you're taking 10 sums, for 10 sums, you're taking around 1 hour to complete. With the same 10 sums can be completed within half an hour itself. So your time will be saved. I heard from your dad that you are really working well. You're working till midnight also, all right, to complete it. Actually, it's a very, very good attitude. Very, very good attitude. Trying to be on time and getting things done. And if you're strong and fast enough, definitely your growth will be in different level. That's the cue which you have to get, all right? By practicing and understanding, these are the stuffs which we learn in 4th, 5th itself regarding additions. Additions of 2-digit number, additions of 3-digit number. We got all those stuffs in before 5th itself, we got this. Okay. So where we are going wrong? This is just a 2-digit number addition. So can we apply that fact? Didn't any book always says this, try to add this. You can easily get a whole number and you can easily get the answer. We are not doing that, resulting in our issue. Is there any other way to add? That also can be done like this. Check. Okay. 8, 8, 16, 24, 26, 28, 30, 3. Okay. 3. 3 plus 6, 9. 9 plus 1, 10, 18, 21, 29, 30. 30 tens, 300. All right. Or else 18, 80 to 100, 100, 100, 300. So find the difference. Is there a way to minimize it? 5, 7, 5, 3. All right. 5, 7, 12, 8, 20, 40, 60, 130, 200. All right. So there are numerous ways of working, and we have to minimize our work, simplify our work. That's why we went through a lot of simplification questions. A chapter known as simplification is not given to you in your earlier classes just to get you 5 marks or 3 marks or 2 marks or 1 mark for that question. It's been done because the person who have designed this whole process the whole book's process as planned such a way that if you start understanding problems, after you completing each and every class or term, you will be strong in your work. That's the reason they started working with it. All right. Okay. Think about it and work on. All right. Okay. You got it? Okay. You got it? Yes. Very good. So this question, this one, I created this exercise with 50 questions. So when you start understanding a pattern, you will understand, oh, it can be done faster, faster, faster. When you're completing this 10, all 50, you would be way, 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 way faster. You would be faster than that 13.5 seconds. Because per question, because you'd have got the idea, your brain would be working faster, faster. At the end, you would be seeing that for the 50 questions, you won't be taking that much time at all. All right. So here we are getting complements of 100. All right. When we add, we may get 100. In the second exercise, complements of 10. All right. Okay. 9 and 1 can be grouped. All right. So 70, 110, 11. 67 and 63 can be grouped. 70, 130, 13. 44, 42 and 48 can be grouped. So this is 50, 90. All right. Here too, again, after completing, here too, there is a group 20, 30, 33. See here, 11 plus 9, 30, 33. So 330. All right. Here, 51 and 59 can be grouped. All right. 11. 53 and 37 can be grouped. 60, 90. 25 and 65 can be grouped. Another 9, 29 to 90. The mind is processing 11 plus 9 is 20 plus 9, 29. All right. It may look like, okay, it's adding immediately 11 plus 9 plus 9. It's not like that. The mind's process is 11 plus 9, 20 plus 9 is easy, 29 to 90. So here in the second exercise, we would be getting simply, we would just simplify the facts. Okay, these two. Okay, these two, these two. We can easily convert it. See here, while adding, I didn't put 110 plus 90 plus 90. I don't need that extra tens. 11 is simple. 110 would be taking more time for me. If I'm putting a 0 also, answer is right. But I would be taking definitely 1 or 2 seconds extra. Why that unwanted one? The last one also, when we are working with this 100, I put only 1. All right. Here and all, I won't be putting this 1 or also 100 and 100, 200. Directly, I will be writing 200. I got the concept too. Okay, 100, 100, 200. 100, 100, 200. So 100. So when I get the concept, I'll be faster, 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 faster. The way you work will give you a better answer. All right, will give you a better answer. That's what we have to do. So this is the exercise which I want you to work really fast. All right, really fast. Think about it. You can easily get to the result. Okay, 1 minute. Okay, now you got it. Okay, well done. Well done. Let's go back to the basics. Your questions, all right? Let's go back to the sum. Two point two we completed. Okay. This is very important, because these are the fundamentals which can be used by you to immediately get the answer. Theory of mathematics is very, very strong. Theory of mathematics is very, very strong. When you understand the theory, definitely you'll be getting a very good answer. If you're not understanding, definitely. Mathematics is not a bunch of questions thrown to you. Someone is going to answer that question, and you're going to copy that question and work on. It's about understanding the fundamental. When you understand the fundamental, whatever question is thrown at you, you can answer any question. All right. Whatever question is thrown at you, you will not budge. You will not wait. Okay, this is the rule. This is the fundamental which I'm going to use. Apply that fundamental. I'll be doing this sum. All right. That's why I'm more concentrating on theoretical type of questions. Understanding the theory, how a concept is developed, why it is developed, what is the reason behind it. If I just have to go with the rules and regulations and all the formulas and everything, by this time, that is, we have spent around 8 hours, all right, around 8 hours. In this 8 hours, we'd have completed more than 4 chapters. The whole chapter would be completed. This is the rule. Apply this concept, do this work, apply those fundamental questions. You can easily proceed. I want you to work on this theories to read through the words, read through the theories too, not only working on the sums. That's why I'm proceeding slowly. All right. This is slow actually. The way I teach, this is slow. A lot of people would think how we can complete this much faster. But actually, I'm really going slow with you because you people don't have that idea of reading those theory at all. You won't be reading any theories at all. Until now in mathematics, the first 3 or 4 pages of a chapter or an exercise, you wouldn't have read at all. You just go with the problems. Okay, this is some important problem. Copy this. This is homework problem. Do this. If you're not happy, if you're not ready, okay, your good friend has already done it. Okay, I will do it. Someone would have gone to a tuition and they would have known it. Okay, ask them. This is not the concept of mathematics. I haven't been in any class, tuitions at all, until 12th standard. They put me in a tuition center for 1 month, and I just quit it in 20 days itself. Because the way they work, they are very slow. I had to look here and there and wait for them. So I propel myself directly. How I propel this? Daily I would be getting up early. By 7 o'clock, I'll be starting from my home, go to my class, sit there. By 8:30, 8:45 only, everyone would be coming. Everyone would be coming. At that time, the time will be very, very quiet. No one would be in the class from 7 o'clock to 8:30. Within the time, I will read through a lesson and proceed for the work. That's how we used to work. Whatever lessons, whatever we are going to do that day, I will automatically go early in the morning, complete the work and proceed. Go, complete your work, proceed. Go, complete your work, proceed. This is how things would happen. Right? Okay. Modular arithmetic. In a clock, we use the numbers 1 to 12 to represent the time period of 24 hours. 1 to 12 to represent time period of 24 hours. That is 2 times 12 would be giving 24. How is this possible to represent the 24 hours of a day in 12 number format? We use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After 12, we use 1 instead of 13 and 2 instead of 14 and so on. That is, after 12, we again start with 1 to 3. This in the system, the number of wrap around 1 to 12. This type of wrapping around after eating some value is called modular arithmetic. So in 7 tape, 7. If I take 7 as wrapping, 7, 14, 21. So I'm wrapping 7. From here, another 7 I would be adding, another 7 I would be adding. So this is just modulo arithmetic, adding a systematic number again and again, right? In mathematics, modular arithmetic is a system of arithmetic for integers where numbers wrap around a certain value. Unlike normal arithmetic, modular arithmetic processes cyclically. This idea of modular arithmetic was developed by great German mathematician Carl Friedrich Gauss. Mr. Gauss has done this. He has given a lot of things on physics also and also in chemistry, right? Who is hailed as the Prince of Mathematics? Okay, Prince of Mathematics, Carl Friedrich Gauss. Example. What are the example we take us? The day and night change repeatedly. Day, night. The days of the week occur cyclically, Sunday to Saturday. A lot of people think Sunday is the last day of the week, but the reality is Sunday is the first day, Saturday is the last. All right, Saturday is the last. Okay, the life cycle of a plant. And while in Christianity we go early in the morning for church to start that week fresh and clear. It looks like a lot of people think that Sunday is the last day. That's why they are going. The reality is the week is starting there. It would be good idea if we go to church and refresh ourselves and go take away all the bad thoughts and everything and look ahead to the new week. That's why that process has been developed, because it is a what we follow is English calendar. All right, that's how they are decided, and slowly everything went vice versa. We think that that's the last day and Monday is the fresh week. All right, fresh week. Sunday is the fresh week. All right, the life cycle of the plant. Check the life cycle of the plant. It will be a systematic. Okay, from fruit to seed, from seed to, from tree to seed, and so on. There is the cycle. Opening, fruit falling down, dehiscing, breaking the seeds and trying to sprout, mature, after maturity, produce seeds and fruits, and again the cycle continues. All right, the season here cyclically, summer, autumn, winter, spring. Railway and aeroplane timing are also cyclical. The railway time starts at 00 and continue after reaching 23:59. The next minute will be 00. So in railway timing, we don't go for 12, 12, 12. It would be a 24 hours timing. Nil, 00, midnight. We call it midnight, right? Midnight is 12 a.m. 12 a.m. is known as midnight, all right? Then 12 p.m., mid-noon, 12 p.m., mid-noon, or noon, all right? Noon. So we use the clock as a 12 parameter. 12 parameter. Then for railway and airways, they don't want to confuse the people. Some people are getting confused with 12 a.m., 12 p.m. and all. So we have to be strong enough and we have to give a right answer. That's why they proceeded with, okay, 24 hours format is itself right. 24 hours in a analog clock will be difficult. 24 hours, 1, 2, 3, 4, 5, 6. It will be very, very difficult. But in digital, it will be clear. That's why they work with digital. That's why they work with digital. Okay, that's what we have to understand. So we also did modulo arithmetic by making you add in that addition and subtraction exercise. I made you add specifically numbers 1, 2 until 25. Again and again for 24 times, I made you add each and every number. Then again, while subtracting a systematic wrapping, 13. Okay, from 225, subtract 13, 13, 13, 13, 13, 13, 13. All right. So that is also a modulo arithmetic. By using this modulo arithmetic, I'm trying to sharpen your mind, not to get the wrong answer. You have to be sharp enough and get the data properly. All right. Fifth. What is this congruence modulo? What is this congruence? Two integers a and b are congruence modulo n if they differ by an integer multiple of n. If they differ by the integer multiple n, a minus b equal to kn for some integer k. This can be, we can take example of 35, 91. All right. If I subtract this 35 and 91, what I'll be getting? Difference between this. Difference is positive number. All right. 91 minus 35. 56. Okay, if I could divide any for 56, does any table strike you? 2, 4, 8, 7, 4. 7, 8, 2, 4, 7, 8. 2, 4, 7, 8. Very good. And this, does these number 91 and 35 could be divided by 2, 4, and 8? Completely divided by 2, 4, and 8? No. Will 7 divide both these? 91 and 35? Okay. See here, when we go for 7, we can easily do 70 plus 20. 21. 70 plus 21. 70 we already know 10 times. So 21 we can get. So it is also getting divided by 7. So 56 by 7 is 8. 8 into that wrap 7. K into n. But k is some integer. N is the integer multiple. Okay, n is the integer multiple. Likewise, we can go on with different examples. Right? Okay. Here are the numbers n called modulus. In other words, a congruent b modulo n. A congruent b modulo n, which means a minus b is divisible by n. What is the meaning of this? A congruent b modulo n. It means that a minus b is divisible by n. A minus b is divisible by n. For example, 61 congruent 5 modulo 7. Modulo 7. It means that 61 minus 5, 56. 56 is divisible by 7. When a positive integer is divided by n, then the possible remainders are, we already came across this in Euclid's division lemma 2. When a number is divided by n, definitely the remainder is 0, 1, 2 until n minus 1. That is, if I'm going to divide 1000 by 7, the remainders can be 0, 1, 2, 3, 4, 5, 6. Lesser than or greater than or equal to 0, lesser than or equal to, lesser than 7, right? Lesser than n. Okay. What we can say is the remainder is greater than or equal to 0, lesser than n, lesser than n. Thus, when we work with modulo n, we replace all the numbers by the reminders upon division by n, given by 0, 1, 2, 3, n minus 1. Two illustrations are provided to understand modulo concept more clearly. To find 8 mod 4, 8 mod 4. With the modulus of 4, since the possible reminders are 0, 1, 2, 3, we make a diagram like a clock with numbers 0, 1, 2, 3. We start at 0 and go through 8 numbers in a clockwise sequence. 1, 2, 3, 0, then 0, 1, 2, 3, 0. After doing so cyclically, we end at 0. Therefore, 8 congruent 0 mod 4. Okay. What we are doing, 0, 1, 2, 3. Okay, 0, 1, 2, 3. Again, a rotation, it goes on. All right. Try it as a clock too. At 3, we can add Okay. All right. Okay. Modulo operations. What are all the other modulo operations we would be working on? Similar to basic arithmetic operations like addition, subtraction, and multiplication performed on numbers, we can think of performing same operations in modulo arithmetic. The following theorem provides this information about this. Theorem 1. A, B, C, and D are integers and M is a positive integer such that A congruent B modulo M and C congruent D modulo M. Then see here modulo M. All right, modulo M. Here it is A, B, here it is C and D. All right, but it's same. The modulo operation is same. If this M is common, we can add these two, A and C. A plus C equal to what's the remainder? B plus D remainder. All right. Then you can also subtract it, A minus C and B minus D. Also multiply it, A into C equal to B into D modulo M. Right. So if you have two separate processes, you can easily from that we can proceed. Let's take an example. Give a 2-digit number and a single-digit number. 24, 8. Okay. So 24 equal to 0 mod 8. The remainder is 0. Okay. Go for the other one. Any other number. 37. 37 is 5 mod 8. All right. This is the case. So what would be the mod of addition of these two? Addition of these two. That is 37, 24. Plus 4. 37 plus 4, 41, 61. 61 equal to, the remainder would be 0 plus 5, 5 mod 8. All right. Let's check for another example also. 45. Let's go for 45. 45 is also 5 mod 8. 5 mod 8. 45 is also 5 mod 8. All right. So at this point, what I'm doing, I'm adding these two. 37 plus 45 is 82. All right. 82 congruent. 5 plus 5 is 10. 5 plus 5, 10. But mod is 8, isn't it? It can't be more than 8. It should be lesser than. So the 10, when I divide by 8, leaves remainder. Right? That's how we have to work on. So subtraction, multiplication, addition, all gives the same result. All right. If I subtract these two, what is 24 into 61? Into 61. It can be 61, can be taken as 60 plus 1. All right. So 24 into 6 is 144. All right. 144. So 144 into 0. All right. 1440. 1440. Plus another 24. 1464 would be the answer. See here, when I multiply this, it would become 144. 6 into 24 would be 144. That too, I'll be 25 minus 1 would be the concept there. So it becomes 150 minus 6. The process which is happening in my mind at that time is 24 is 25 minus 1. So 150 minus 6 is 144. Since your mind is accustomed to it, it may look like you're answering immediately. But the reality is the process which is going on is 24 into 6 itself would be like 25 minus 1 into 6. So this is 150 minus 6, 144. So I'm multiplying with 0, 10, 40 plus 24 into 1, 24. So I would be raising 20. 14, I will not consider this at all. 14 would be just like that. 40 plus 24 is 64. So that split seconds is what I'm needing to proceed. So 1464 equal to, I multiplied both this number. All right. Leaves the remainder 0 into 5, 0, modulo 8. Definitely, these two also would be leaving the remainder 0 when you multiply. Right? Let's check. Can we check on it? 14, one time. 6, when I divide by 8. 66 is 8 times. Remainder 2. 24 is 3 times. Yeah, it's leaving a remainder 0. All right. That's what we have to do. 17 congruent. 17 equal to 17 congruence 4 modulo 13 and 42 congruent 3 modulo 13 from theorem 5. Let's check with theorem 5. Both are 13. 17 plus 42. 9. 7. Yeah, it leaves the remainder 7. When I subtract, remainder also would be subtracting. 4. Okay. 4 minus of 4 minus 3. 1. Okay. For minus 25, it would be leaving the remainder 1. It would be moving in the opposite direction. Remember? All right. Opposite, anti-clockwise direction. So a lot of people would get confused when this minus comes. We are not accustomed to minus. All right. So we have to be careful with it. Then 17 into 42. 4 into 3. 12. Okay. This is lesser than lesser. So it's not a problem. Definitely it's also true. Okay. Well, definitely it's also true. You got it? Then theorem 6. If A congruent B modulo M, then if I multiply both any number, same number, that is also congruent. Or when I plus or minus any number also, that also would be the same. It will not be any change. If it's A equal to B mod like this, any 2-digit number and a single digit number like this, 32. 9. So 32 and 9, it would be 32 congruent 5 mod 9. Okay. If I multiply this by 2, this is also would be multiplied by 2. 10. So 10 we can write here. So 10 minus 9, 1. It becomes 1 mod 9. All right. If I'm adding 2 plus 2, I'll be adding plus 2 here also. It becomes 7. If I minus 2, 30, then it becomes 5 minus 2, 3. Whatever you multiply or whatever you add or subtract, it will be same. If it's done on both sides, it will not be changing at all. That's what they are working here. Okay. The positive values of k such that k minus 3 congruent 5 modulo 11 are. They want a positive value which when divided by 11 gives 5. Remainder as 5. Positive value of k. K should not be negative or 0, only positive. If I put 1, it would become different. So what the positive value of k such that k minus 3 congruent 5 modulo 11. Remainder as 5, which should be divided by 11. 14. 13. Okay, 19 minus 3 is 16. Okay. Why not k minus 3 equal to k minus 3 equal to 5? Why not? Is k minus 3 equal to 5 not possible? Leaving the remainder 11. See here, when I divide 5 by 11, it leaves the remainder 5 only. All right. So this is also possibility, isn't it? So k minus 3 equal to 5. When I add this 3 here, it becomes 8. For 8, it forms remainder 5. For value of k equal to 8, it forms remainder 5. From that point onwards, we can just add 11 to it. 19 would be the answer. Next one would be 90. Next one would be 30. For the values 8, for the values 8, for the value 19, for the value 30, it will be leaving a remainder 5. 59 congruent 3 modulo 7. 46 congruent 4 modulo 7. Then 25 congruent dash modulo 7. You want to divide? Mriduma, you can use a note if you want also. It's not a problem. All right. Or else try to check the step. You easily know until 10, isn't it? 70. Subtract that 70 here. Becomes 35. Yeah, 0 remainder. So you're taking you're complicating things in your mind. You're not segregating it. What I really want to teach you is Mathematics is a simple concept. When you segregate it, you'd be getting the answer easily. When you're not segregating, you would get confused. All right. Modulo arithmetic, definitely most of the schools won't be teaching at all. All right. Because it may not be important in exam point of view, but future point of view, modular arithmetic is very, very important regarding aptitude, regarding that exam which I told you have to write net. Those exams all require your speed and understanding. For that, modular arithmetic is really important. Divide it and get the result. Don't wait for it. Don't wait for it. Okay? Okay. Check here. 13 congruent. Dash should be the remainder when divided by 7. Okay. 13 minus 7. 6 would be the remainder. 413. Whoa, here it's increasing. 413. Try it. You don't have to go for 70 here. We know 35 is 350. 7 into 10 is right. 7 into 50 is 350. So we can easily minus 300 first. 350 can be separated. Okay. If I minus 300 from 413, it becomes 113. If I minus 50, 63. I know 63 is divisible by 7. Okay. Right. Check here. First you went very good. The way you processed 70. Good. 70, 70, 70, we can easily minus. Here we can easily check that the value can be reduced considerably. 10 is okay. How about 20, 30? The last two digit can be easily checked, isn't it? See here, 35. 350. So with this last two digit itself, I confirm that in this last two digit, 1 will be remaining. 18. So 18, 14 minus 14, remainder 4. See, we can easily simplify it. All right. The remainder, wow, check this question, what they have done. The remainder when 7, 13, 19, 23, 29, 31. Why? How come? Okay, 13. 19 leaves 1. Okay, 1. 23. 23 is, what is the remainder for 23? 23 minus 18, 5. 5. Then 29. 5. So 1, 1, 1, 1, 5, 5. Multiplication is there. So we have to multiply, isn't it? 25. Okay. 25. And definitely for this 25, if you divide by 6, you'll be leaving remainder 1. That's why I asked how you got that 1. All right. Sometimes it will change completely. If it's 22 here, the remainder would be 4 into 5, 20. Remainder would be 2. All right. So addition, what and all remainder you can add. For subtraction, what and all remainder we can subtract. We have to be sharp enough with your question. Understand that? That's why we work with these. This question is like, okay, theorem 6, what's it? It will be leaving the remainder this. All right. This theorem is getting applied there. This theorem is getting applied there. Nothing more, nothing less. All right. Okay, think about this. Find the remainder when 70,004 and 778 is divided by 7. We can easily segregate 70,000 plus 4. 70,000 plus 4. 70,000 would be divided by 7, no problem. 4. Yeah. Here 770 plus 8. 8 will leave remainder 1. See here? The large explanation will be cut short into simpler one. Okay. Determine the value of D such that 15 leaves a remainder 3 when divided by D. When I subtract 3 from 15, it becomes remainder 0, isn't it? 15 minus 3, 12. 12 equal to K into D. All right. Or we can say Q into D. If you are okay with Q quotient, it's fine. So D divides 12. What and all numbers that divides 12? 1 would be dividing 2, 3, 4, 6, and 12. D should be larger than 3. So the possible values of these are, definitely it should be, the remainder is 3, isn't it? It should be greater than 3. We can't take the lesser number because the remainder can't be lesser than the dividend, denominator, right? So that's what we have done here. So these 3 are not the answer. 4, 6, and 12 would be the right one, which would give the remainder 3. All right. Here, find the value, find the least positive value of x such that 67 plus x congruent 1 modulo 4. When I divide this number, the 67 plus x by 4, remainder will be 1. So first I will take this 1 here. It becomes 66 plus x equal to 4n. All right. 4n. So 66 plus x is the multiple of 4. Therefore, the least positive value of x must be 2. Multiple of 4. If I add 2, if I add 1, it becomes 67, which is not divisible by 4. If I add 2, 68, it is divisible by 4. So 68 is the nearest multiple of 4, more than 66. All right. Here, 98 minus x minus 4. This whole x plus 4 should be going other way around. So a lot of people will forget to multiply this minus x minus 4. All right. Then 98 minus 4 is 94. 94 minus x is 5n. So for what value of x will be the multiple of 5? If I subtract 4, it becomes 90. All right, 90. So the nearest multiple of 5 less than 94 would be this. Okay. When solving congruent equation, we get infinitely many solutions compared to finite number of solutions in solving polynomial equation in algebra. In polynomial equation, we will be getting exactly one answer. If it's 8x equal to 64, x equal to 8. But here in congruent, it will be totally different. Congruent, it will be totally different. So we'll be having many number of solutions. Many number of solutions. One would be minimum number. Others may be going on. All right. So 8x modulo. So 1 goes here. All right. 8x minus 1 equal to 11x. So when I divide, I need x. So minus 1 goes here. it becomes 11k plus 1, x equal to 11k plus 1 divided by 8. If I put k equal to 1, k equal to 0, x would be 1 by 8. If I put k equal to 1, 12 by 8, 12 by 8, which is 3 by 2. When I put k equal to 3, 33 plus 1, 34 by 8. Okay, got it? If I put k equal to 2, 22, 22 plus 1, 23 divided by 8. It won't be divisible. This would be 17 by 4. All right, so it goes on. All right, all right. Put the value of k equal to x equal to 5, 13, 21, 29. All right, 21, 29. This is 55 plus 1, 56 divided by 8, 7. All right, 7. 11, 13, 11 into 13. What is 11 into 13? Super. 143 plus 1 divided by 8. 144 divided by 8. All right. Here too, we can easily segregate 80 plus 64. 80 when divided by 8, 10. 64, 8. So you can easily combine those two and get the result. All right. Or else 160 minus 16. 160 divided by 2 is 20. 20 minus 16 by 2 is 16 by 8 is 2. So 20 minus 2. Both way we'll be getting the answer. All right. The solution is very simple. All right. The solutions are very simple. 7, 18, and goes on. When we check, it would be exactly addition of 11 with these numbers. Because that will leave the integer. This will be real numbers. This will be a real number. But we need an integer, isn't it? We could see that 1, 2, 3, 4, 5 is 1, 2, 3, 4 is not providing the result. If I put 4, 45 by 8, never. We'll be getting in decimal points. No. If I put 5, 55 plus 1. From that point onwards, you can just add extra numbers to get the result. All right, extra numbers to get the result. Check it. The solutions will be exactly when I get the first one, addition of that same 11 would be giving the answer solution. All right. Compute x such that 10 power 4 modulo x congruent x modulo 19. 10 power 4 is 10 squared, 10 squared. Yeah, 10,000. It's a big number, isn't it? It will be difficult for you to work. So we can convert into 100 into 100. We know, isn't it? A into B. It can be divided. So what would be the modulo for 100 when divided by 19? 5. So 2 times 5. 5 into 5, 25. The remainder would be 25 into 25. Now, 25 minus 19. 6. Got it? Okay. All right. We can, for 10, if we can take 10 also as a fundamental, but 10 doesn't get divided, isn't it? So 100, okay, we can easily segregate it. That's why we went like this. All right. Find the number of integer solutions. Okay. 3x congruent 1 modulo 15. When I divide this 3x by 15, I had to get the modulo 1. So minus 1, 3x minus 1 equal to 15k. So 15k. Yeah, good. We get 15K plus 1 by, if we segregate, they are segregated it, all right, they are segregated it. We can be sharp. We can be sharp also with this, okay? When we check that, it is 15K by 3. Automatically, this 15K is getting divided. The remainder, 1 by 1, won't be dividing by 3 at all. So there is no integers to provide for you. There is no solution in integer part. There is no solution in integer part. But if we put k equal to 1, we'll be getting 16 by 3. If I put k equal to 2, 31 by 3. K equal to 3, it would be 46 by 3. See, there will be exact additions of 15, 15, 15, 15 to the numerator. Since there is a denominator, it is not an exact complete integers, we can say there is no solution. All right. So this integer, specification of that integer, a lot of people would be confused with it. Definitely it will happen. When you understand the fundamental, you will get the data. All right. That's what we are working on. Mostly they would be skipping. I could just give some 5 to 6 example and proceed with the problems just like that. But I don't want to do that because the theory is 1 mark and some of the 2 mark questions would be having questions like this. If they get questions like this, they will say, okay, it is a difficult paper. All right. There's nothing such as difficult paper. It means that we have left something out. If a paper is difficult, we say it's difficult, it means we have left something out. That is the reality. That's the reality. Okay. Don't worry about the consequences. You just work on it. Okay. A man starts his journey from Chennai to Delhi by train. He starts at 22:30, 10:30 p.m. on Wednesday. It takes 32 hours of traveling time, and assuming that the train is not late, when will he reach Delhi? Not late. Uh, 22 hours. Within that, another 24 hours, it will be again 22:30. Wednesday, 22:30. All right. Another 24 hours. When we complete the 24 hours, it would become Thursday. Thursday, 22:30. 24 is completed. All right. Remaining 8 is there. All right. And it would become Friday in another 1.5 hours. 00. Friday. All right. Friday, another 1.5 hours. So after using that 1.5 hours, balance is 6.5 hours. So Friday, 6:30 a.m., he'll be reaching the place. Use your mental ideas too. Automatically, you would be getting the result. See? 54:30. Okay, modulo is 24. So what is modulo 24? Automatically, we added the 32. This is the reminder. We added the 32. We'll be getting 54:30, 48. When I subtract this 48, I'd be getting 6:30. That way I'm getting the answer. Okay. Kala and Vani are friends. Kala says, today is my birthday. And she asks Vani, when will you celebrate your birthday? Vani replies, today is Monday and I celebrate my birthday 75 days ago. 75 days ago. Find the day when Vani celebrated a birthday. Good. Today is Monday. I celebrated my birthday 75 days ago. Okay, 70 plus 5. 5. You have to go back 5 days. Let's check. All right. Okay. See here, since it's going back, it's negative. You got the right answer. By normal method itself, you got the right answer, right? You have to think intuitively too, all right? We can go through the data too, but when it comes to modulo arithmetic, it is minus 74, all right? Because the 75 crosses 0, then crosses the other day, all right? So from day 1, Monday, it is going 0. This is 1, 0. That's why we put minus 74. We'd be getting minus 4. Minus 4 is not possible. So what we will do, we will segregate it by subtracting that 7. Subtracting minus 4 from 7. That would be the modulo. All right. So when we get that 3, we can say Monday, Tuesday, Wednesday also. You can go back by taking 75. By taking 75 mod 7, you can go back 5 days. All right. 75 mod 7 is also right. 75 mod 7 is also right. You're getting 5. So take that 5, you can go back. It's not that exactly you have to take minus 74 here. All right. With 75 also, you'd be getting the same answer. All right. Wednesday. Good. With that as an idea, proceed. All right. Proceed. And let's check how we are going to work. All right. See, what is the time? 100 hours after 7 a.m. (24 into 4 is 96. Yeah. Stick to the question. They didn't give first day, second day, third day, fourth day, and all. What is the time after 100 hours? 7 plus 4, 11. Leave it like that. Don't go for extra details. Look at the question. Make it simple. Proceed. Okay. Good. What is the time? 15 hours before 11 p.m. 6 a.m. How come? 11 minus 10 is? See, 15 hours can be computed with 12 plus 3. So before 12 hours, it is 11 a.m. All right. So another 3 hours before, 10, 9, 8 a.m. Okay. 8 p.m. All right. Yeah, 12. So these kind of questions will be interesting. When we understand the fundamental, you'll be getting the result. Okay, no problem, no problem, no problem. All right. Think about it. You'd be getting the result easily. All right. Okay, good. Prove that 2 power n plus 6 into 9 power n is always divisible by 7. Always divisible by 7. For any integer n. This I will teach. Don't worry. You don't have to break your head with this. There is a basic fundamental. When you understand that basic fundamental, you'd be free of it. All right. Don't worry about it. Leave it aside. I will teach you tomorrow. all the other questions, which is possible for you, you have to work. All right. If there is any issue with the answer or something, we can check why we got the wrong answer and correct those mistakes. All right. Find the remainder when 2 power 81 is divided by 17. 81. Okay, what is 2 power 5? 64. Think properly. 2 power 5. 32. You can go on with 64 also for 2 power 6. Okay. Let's go for 2 power 5 itself. All right. Why I want to go for 2 power 5? Let's check. Idea. I'm just giving idea. 32. When divided by 17, leaves remainder 18. Is that so? Sorry. Leaves the remainder 15. Okay. So this is 2 power 5. 80. How many times 2 power 5 becomes 80? 80 divided by 5. 80 divided by 5 would be leaving 5. 6. 80 divided by 5. 16. Okay. 16. So 16 times into 16. All right. I'm telling the reminders. 15 times remainder 16. 16 times remainder 15. So automatically I will multiply this. What is 15 into 16? See here. 16 plus 5, 21. It means 210. I'll teach this concept for you. All right. 210 plus 30. 240 would be the answer. Another way of multiplying is, you can, if you have any number multiple with 5 and another number is even number, just half it. 8 into 2. 16 into 15 into 2 is 30. 3 into 8, 24. 240. Yeah. If it's 65 into 58, this is 65, 58. Okay, half of this is 29. This becomes 13. Now I can easily multiply this easily. That is 65. Doubling is halving this and doubling this. Multiplying and dividing by 2. That's what I'm doing. All right. So it becomes, now it is simple, isn't it? 65 into 58 is some kind of hard. 13 into 29 is simple. So this one also 30 minus 1. So 13 into 3, 39. 390 minus 13. All right. See, there are numerous ways of understanding math. Okay. Yeah. So I will teach you that. Now, after this questions or after the questions, I'm going to give you that one. Right? We are going to work on that. Right? 8 into 2. Like that, you got 240. Now, this is 240. We can easily say 240 divided by 17. 170 is possible. 10 times, remainder 70. Okay. So you can easily segregate, isn't it? 240 we got. 240 into 7 is there. All right. We segregated it simply. All right. 170 can be segregated. Balance 70 is there. Again, in 70, 65 can be removed. 17 5s are 60. Okay, that can be removed. All right. 17 5s are, sorry, 85 it would be. All right. 85. 17 5 is 85 it would be. Okay. That we have to, we have only 70, isn't it? All right. So we can't go for 5. We can go for 4. 17, 34, 34. 2 times is 34, ma. 68, ma. Doubling it is 68. This is doubling 68. Here 70, no, remainder 2. So out of this, the remainder is 2. 2 into 7, 14. That would be the remainder. That's, if it's more, I have to travel further. Sorry, until this 2 power 80 we found out. 2 power 80 we found out. The remainder is 2. Into 2 is there. So the remainder will be 2 only, isn't it? 2 into 2. 4 would be the answer. 4 would be the answer. All right. So we are just segregating and getting the result. All right. Segregating and getting the result. 10th. The duration of flight travel from Chennai to London through British Airlines is approximately 11 hours. The airplanes begins a journey on Sunday, 23:30. If the time at Chennai is 4.5 hours, head to that of London. Find the time at London. When will the flight land on London Airport? First question would be, why they are given 4.5 hours? Actually, GMT is 5.5 hours, isn't it? With India and Greenwich Meridian, which runs across London, is 5.5 hours, isn't it? You didn't have any idea about it. 5.5 hours difference. GMT, Greenwich Meridian, which runs across London, and ours as a difference of 5.5 hours. Okay, so that would be definitely different, but they are given 4.5 hours. Okay, all right. The flight duration is approximately 11 hours. 11 hours. So find the time at London. When will the flight land at London Airport? When will the flight land at London Airport? Good question. Begins a journey. They are given it as begins a journey. Begins a journey at 23:30. Night 11:30 is starting. What's this? 10? Okay. After 11 hours. This is 30. Okay. After 11 hours, if you why you added? You are done Australia timing. Your flight, you got it. Did you see this movie Home Alone? You got into the wrong flight. You went to Australia. Very good. Well done. Right? Well done. So when you understand that question, your answers would be really, really simple. Right? When you simplify the things, definitely you'll be getting the result. Right? Think about it. Modulo arithmetic, they think that these are not important. They will just work for 1 marks alone and they will proceed just like that. But the reality is totally different. Understand the reality. We have to face the reality in future. They may say that, oh, this is not important. This is okay. This is that. Because of this, a lot of people are missing UPSC exams. Couldn't clear the UPSC exam. Couldn't make it simple, make the question simple. So understanding is required. Actually, your school would be almost neglecting this whole exercise. All right, whole exercise they'll be neglecting. They'll be concentrating on Euclid division lemma and the next part, which is very, very important. In exam point of view, AP, GP, sum of AP, sum of GP, and special series. They will concentrate on this. They don't consider this as important at all. And the importance of modular arithmetic would be understood only when you move ahead. You want to become a different person. If you're not working on difficult stuff, always you will try to find easier methods. That is not the right thing to do. So make sure you go into that. All right. Check whether your brother is there. Is that so? Okay. So இந்த எக்ஸசைஸோட இம்பார்ட்டன்ஸ் கருவி தான் வந்து இவ்வளோ டைம் எடுத்திருக்கோம். இவ்வளோ நாள் நம்ம படிக்காதனால அப்படியே வந்து போயிட்டே இருக்கு. இதை நான் ஜென்ரலா சன்ஸாவே போட்டுடலாம். ஆனா ஓகே, யூ ஹேவ் டு அண்டர்ஸ்டாண்ட் அப்படின்றதுக்காக நான் வந்து சொல்லி கொடுத்தேன். ஓகே, we can proceed to the next one. Okay, ma'am. This one. We already know how to multiply. When it's in 11. Just add the number, insert the number in between. So what about multiplying this 12 to 19? Any numbers between 12 to 19? That's what we are going to see. All right. Okay, first I want you to answer. What is this 13 into 17? You can use your note also to work out. What is 13 into 17? Do these things also. 15 into 17, 13 into 16. $255. What about 12 into 14 into 18? Okay. Okay. Good. See how much time and how much written work you have to do. All right. We are even above average and above average person. Top 5 people in the class also would be doing the same multiplication steps and everything, which is really time consuming. But they think that since they are already satisfied with the ranks and everything, they are not working on improving this. Right? Which question you want me to answer from this? 216, 225, 303, 13 into 9, 247. Right? Okay. What's happening here? Let's check into that. All right. What you have to do is select a question out of these 2%, which is the bigger number? 18. 18, add the unit digit of the smaller number. 18 plus 4, 22. 4 8s are 25. Right? So it means that what it means is we got this 22 isn't it? It means 220 into 10 is 220 plus 32. 4 into 8, 32. 220 plus 32, you can easily answer. How I answered is like this. If I write that like this, I'll just write 22, 4 8s are 32, 3 and 2 and add it. If I'm doing it in mind, I'll add this 4 first. 22, 220 plus 32. I'll be getting the result. All right. When it goes here, this is also 22. 220 plus 35, 255. Okay, 255. 19, 190 plus 18, 208. 20 plus 21, 221. 200 plus 21, 221. Right? When it goes here also, it's almost the same. 323. How? 26. 260 plus 63. 323. All right. 13 into 19. 22. 220 plus 27. 3 9s are 27. All right. 247. 20. 12 into 18. 20. All right. 20. 200 plus 16. 216. 5. 20. 200. That is 200 plus 25. 225. All right. It looks like, wow, how can we? All right. But the method which we follow here is this one. 10 plus 5, 10 plus 6. You can add any number. You can add 5 or you can add 6. It will be same. Why I select the bigger numbers? To a bigger number, a small unit digit addition is very easy when compared with a smaller number getting added with bigger number. All right. Our mind would be at ease. 18 plus 2 is easier for a mind than 12 plus 8. Right? So understand that it will be easy for us. That's how our mind works. All right. For addition, select the bigger number, add the smaller number, it will be easy for you. So now you can say 19, 17 plus 2, 19, 190 plus 14, 204. Good. Well done. You got it easily. 21, 210 plus 24, 234. 200 plus 24, 224. 250 plus 56, 306. 24. 24 plus 48. 48. That is 240 plus 48. 288. See, when you start practicing, your mind will start accustomed to it. Hey, what are the questions? Oh, this is the answer. Yeah, this is the answer. This is the answer. It will look like they are fast. We are stimulating our mind in such a method that you took almost 2 minutes to complete this. Say will be completed in half a minute. Half a minute will complete this 4. So the remaining time will be safe for you. You can easily work on any other extra drawings or something like that. That's why this chapter is important. All right, this one is important. We'll be using a lot of these multiples. That's why we need this. Okay, think about it and proceed in that manner. All right, well and good. I'll just take printout of both addition exercise and this one. All right, definitely make sure to work on that. We only had one exercise. I want you to go through the theories properly. This would be the final time you would be reading that lesson, that chapter, that exercise. Next time and all, you're just going to revise it. All right. So one time you do it with proper method, then we can proceed. Those theoretical questioning exercise, we will definitely work that exercise tomorrow. Exercise problem tomorrow. All right. Try to work it out. If not, it's fine. We'll work those 2 theoretical questions, the 9th and 10th question. We'll work it out properly. All right. Okay. Thank you then. We'll stop recording.